Hi, Shanielle.
Hello, good morning.
How are things going for you?
Good.
Our last week,
Yeah.
how's it feeling? Do you have a lot of work piled up at the end here?
Yes, I do.
Shoot. Why does it always end up like this, right?
Yeah.
End up with
I
filing at the
I
end.
kind of fell behind for a while.
So how far are you in our class here? Do you recall, are you, I don't have your, I don't have your material right in front of me. Are you on, what chapter are you on? Do you know?
No, I don't know. A lot has been really hard for me lately. I haven't really got any work done.
Shoot. You have such a good start in this course. I really want you to see
Yeah.
through it. Do you foresee for yourself time to just concentrate on this a little bit before the term ends?
Yes, I really want to catch back up.
Yeah, I think you'll just, if you can just find a way to concentrate, and I can be available anytime you're having trouble. I've tried to put really good recordings together, so if you follow them, you should be okay. But you've done
Yeah, I got most of the assignments done, but I just never really submitted.
oh, that's okay. All right, well, get them submitted and I can get you some feedback on them. That's terrific.
Okay. Okay, thank you.
All right, well, we're going to start right on time today, even though you're the only one here, because we just have, maybe I'll give a couple more minutes here. We have so much to cover. Hi, Katana. We're going to go through a bunch of content here today and hopefully clarify everything, because this is, we're not going to cover chi-square. We're just going to stop here and I'll talk, and as soon as we get some more people in here, I'll get started. All right, well, we have a few people here, and I think we'll go ahead and get started. I see here, let me see again who's here. I see Katana. Doris, nice to see you.
Hi.
I miss you up in our little classroom, but I guess that's what it is for now. Kiana?
Yeah.
Your voice is working in okay? Kiana?
Yeah, I can hear you.
Cool. All right.
Good morning.
Good morning. Well, nice to see all of you. So we'll get started today. So first off, this is our last class period. I mean, this is our last class period where I'm going over content for homework. Our next class period is just going to be a review for a little multiple choice type of final exam that we'll be having. So we're going to spend all of next class just reviewing for that so that you can be prepared. Excuse me. So today we're going to just stick with correlation because I haven't seen work on this yet. So we're going to go over a few different things today, and let me put up my screen. So There you go. You should see a blank screen right now. And let me pull my content over. All right, so this is what we're going to cover today. We have, so as I said, today is the last day of going over content for the homework. Excuse me, yeah, got something going on here. And so we're going to cover, first we're going to have a little bit of a review of correlation, just so we remember where we were. It's been a few days, a long holiday and all of that beautiful stuff. Now we have this last week of our class and I'm just trying to reverse this here. There we go. All right, our last week of our class, and then we have our exam week and we're all done and we get a few weeks to prepare for kind of the next holiday, which will be very nice. So I hope everyone's feeling good. And I know it's kind of a big increase in intensity as we wind the semester down here, but then it's over and behind us, and hopefully everyone has a good grade in all of their classes. So today we're going to start with a brief review. Then we're going to go over those 3 alternate explanations, doing a few practice problems together. Then we're going to look at correlation matrices, which I haven't formally talked to you about at this time. And then we're going to go through an example problem. So your assignments for chapter 11 are the same as for the others. There's a practice assignment where you should solve a problem and then check the key. And that's super important. It's not important that you get your practice problem right on the first try. It's very important that you do review, find out where you went wrong, because if you find out where you went wrong, then you won't make that mistake again. So let's get forward. So just a bunch of points here, and then I'm going to give a couple examples. So correlation, again, is like just using 2 data points from each person. So each individual in your sample has 2 data points. And we gather those 2 data points from a large number of individuals to see whether there's a relationship between 2 variables. So by relationship, we just mean that as the values in one variable change, like as they go up, then the values in the other variable change in a predictable direction. Either they tend to go up or they tend to go down, but we can predict it. That's what we mean by relationship. We use what we call a scatter plot to plot the points. We can determine the direction of the relationship as positive or negative, and that just means whether the points tend to go upward or downward. And we determine the strength of the relationship by how far the points are from a line that fits into those points. And the figure we use to measure it or to quantify it is called the correlation coefficient, that is represented by the letter R. So I'm going to just give a little example of this by gathering data from each of you who are here today. And we're just going to talk about it initially, and then we're going to solve the problem with your own data at the end of this class. So let me just get a blank slide here. All right, so what we mean by 2 data points from each individual is we imagine that there's a relationship between 2 variables. And for the sake of our example, I'm imagining that there's a relationship between the hours of sleep a person would get and their mood the next day. So let's say I'm a researcher and I'm hypothesizing that there's a relationship between those 2 variables. So in that instance, I'm hypothesizing, so our variable 1, whoops, I might draw up here. So our variable 1, I have to get on a different glove here. Whenever I don't wear my glove, then my my screen responds to just the touch of my hand, and that makes for a very messy presentation. So I have to put on a weird glove here, just a moment. All right, variable 1 in this case, we're going to name the variable X, and I'm going to call it sleep, because I'm predicting that sleep might impact mood. Variable Y, I'm going to say mood. And I'm just going to say sleep, I'm going to measure by a number of hours. Mood, I'm going to measure on a scale of 1 to 10, with 10 being like in a great, perfect mood and 1 being in just a really horrible mood. And I'm going to gather data from each of you who are here. So what I'd like each of you to do is right now, send me 2 numbers. And I'm going to write your names down so I can get the data, write your initials, Shanielle, Kiana, Doris, Kitana, and I'll include myself in this as well. And so the numbers that I'm going to say are, I'm going to say I slept, gosh, I was working so late last night. So I slept, but I got good sleep anyhow. I got 6.5 hours of sleep. So that's my value for the variable X. And my mood, not too bad. I'm going to say actually it's also about 6.5. So now I'd like each of you to go into the chat and submit me your 2 variables. Put your sleep numbers first and your mood number second. And your mood is just on a scale of 1 to 10. Once I get that, I'll record these data. And in fact, I'm going to just slide something over so I can, while you're giving me those numbers in chat, let me request that in case your attention lapsed for a moment here. All right, I see a couple of chats. All right, thanks, Shanielle. I have a 7 and a 6, a 3 and a 6, a 6 and a 5. Let me move this over. So, and 6. Arthine, I didn't see you there, sorry. We have 5 and 7. 6 and 5, 6.5 and 6.5. Let me see who else we have in our chat here.
Good morning, Ms. Ross.
Hi, Kyle, good to see you. Everyone's
too.
giving us their number of hours of sleep they had and their mood today on a scale of 1 to 10. If you feel like throwing in some numbers for us in the chat, we're just asking how many hours of sleep you got and what your mood would be on a scale of 1 to 10, with like good mood to bad mood. I don't have Doris's yet. Maybe she's stepped out for a moment. So Kyle, 8 and 10. Very good. I like that. So Kyle, 8 and 10. All right. So this is what we mean by 2 data points from each individual. So when we talk about a scatter plot, as you know, what we normally want to do is put our Yolanda, we have one more. Let's put it down here. Y, E, 7 and 7. All right, we better stop here so we can get moving. So here's our scatter plot. So we always start out by having our axes fairly equal. These lines are called our axes. On our x-axis, we put the variable that we think might predict the other. So we sort of think that sleep might predict mood. I'm going to just put X up here for sleep. Sleep. And Y is mood. All right. So here we have our x-axis. We'll put sleep here because we think that the sleep is going to predict mood. We just range our values all the way from one end to the other of this continuum. We can approximate the lowest and highest values. Like in this, I would probably run maybe from 5 to 10. I mean, 5 is our lowest, so we can start right there. 10 is our highest. We don't always have to have the exact lowest and highest. Some situations don't warrant that, but let's just put 6, 7, 8, 9, 10. We try and space them evenly. And on the y-axis, we're going to put mood. And we'll just put the lowest. Oh gosh. All right, I'm going to do this all over because I just realized that I put the wrong variable on the wrong axis. You guys can always correct me when I do mistakes like this. So let me just, there we go. I'm just going to do this over because I accidentally mixed up my axes. And I think I'll get a different color pen so that we don't get our data mixed up with the, there we go. All right, let's do this one more time. So here are our axes. When you do these, I'm just drawing this again because the couple of examples I saw, this wasn't necessarily quite right. So here we're going to put on the x-axis sleep, on the y-axis mood. Now we put our range in, and so for sleep, it looks like the highest is 8, the lowest is 3. Just for the sake of going a little bit even here and making it easier to parse out, let's put 2 to 8. We just won't have any values at the lowest number. So 3, 4, 5, 6, 7, 8. I'll put 5 in the middle here, and 6, 7, 8, 4, 3, 2. I'm really sorry for Katana here with 3 hours of sleep. I hope you get more sleep tonight. That's really hard on those low sleeps, especially if it's more than one night in a row. And then let's put 5 here. We'll go up to 10 on the top, and we'll put 5, 6, 7, 8, 9, 10. All right, now we're going to just plot out the points. If you follow along with this, sometimes it's really good practice if you do it yourself. So let's plot our first participant, 7, 6, and this person is right about here. Our second, I'll put 1 here. Our second is 6 and 5, way down here. Our third is 8 and 10, way up here. I'm numbering them so I can just keep track of how far I am. Our fourth participant is 3 and 6. 6.5 and 6, someone has to be complicated with those half numbers here. And 5 and 7. And 7 and 7. All right, I don't see too much of a relationship there, but when we have just a few data points, it really is harder to detect these. Normally, ideally, you would want to have a minimum of 30 participants, but for these little in-class examples, we do it like this so that we can do the mathematics more easily. But I would say that if we were going to draw a line of best fit, maybe it would go, I think that this value up here is something of an outlier because I think our line might have gone like this, if not for the outlier. And I think that the outlier, let me see here. No, I want to undo that. I'll just take a different color. I think that the outlier causes this to be a weaker correlation because the line of best fit to incorporate that outlier probably looks something more like this. Either way, it's a linear. How would you define this relationship, everyone? If you were going to put a term, a phrase to it, would you say it's positive or negative?
Is it positive because it's going up?
The line is going up, so this has got to be positive. Thanks, Kiana. Yes, and that's just the direction of the line going in this upward direction. So we know it's going to have a plus value in the correlation coefficient. How strong do you think it is? Like a 0 correlation, if you'll recall, a 0 correlation that has not much going on, has just this cluster of points that goes like this. hard to even see where the line is. We'd say a weak relationship is probably, maybe something like that. You can sort of see a line. A strong relationship would have the points really tight to the line like that. Where do you think we are in this? Moderate, weak, strong? Arthene thinks weak. I think that's probably a pretty good guess. So maybe we put a correlation coefficient on this of plus 0.3 or something like that. Okay. So just to review those terms a moment, and we're actually going to solve this problem in a little bit. Well, maybe we should just solve it right away. So just to put a little bit of a okay, so that's all I'm going to say. So these are the data that we're going to work with today. This is the problem we're going to solve at the end of class. We're going to just do it all together, start to finish, including just typing the variables into whatever we're going to use. So now let's go on and think about this relationship. Let me just ask, if this is, let's imagine that we find that this is a moderate, we get more data points, and we find that this is a moderate relationship. Does that mean that sleep, absolutely, do we now have proof that sleep causes a change in mood? And the answer to that question is always going to be no. Even if this is a strong relationship, it doesn't mean that sleep causes mood, not necessarily, because it could be that sleep causes mood, but there are a couple of other alternate explanations that prevent us from saying that with certainty. So let's pause here. We're going to revisit this in a little bit, and let's look at these alternate explanations using some examples that I've prepared for us. So what we have here is a correlational result. So we have a relationship that suggests that, I wonder if I can minimize this. All right, so a significant positive relationship exists between money spent on a car and liking for that car. So in other words, someone spends more money on a car, they like their car better. That's what this is suggesting. Okay, so imagine that this is true. All right, first question, what are the two variables? Like in this case, what are the variables X and Y? So everyone go ahead and just name the variables if you can in the best way you can. Or why don't we do this one together? I have 3 examples for us. Let's do this one together, and then we'll do the next ones with you providing answers. So the two variables X and Y, I would say we're looking at money spent on a car as one variable and liking for that car on another variable. So let's write those in. I guess I'm going to list money spent as the X variable. So money spent on car. And I'm going to name it X. And I would say that Y is liking for a car. And let's leave it like that. So I think that these are probably the two variables, and I think that's a good way to name them. So we'll leave that. So now this next question, since it's a positive relationship, does liking for the car increase or decrease when more money is spent?
A decrease?
So let's just think about positive and negative relationships. So if you have a good relation, let's imagine like you're actually in a relationship with a person. If your relationship is a good relationship, you're both going in the same direction, right? As one of you goes up, the other of you goes up. As one of you goes down, the other of you goes down. That's positive. This might be a way to remember it. If you're in kind of a bad relationship, you're kind of going in the opposite directions, right? It's a negative relationship. As one of you goes in one direction, the other of you goes in the other direction. You're parting ways. So in this case, and this is just a metaphor, but it might be a way to remember it, that if it's a positive relationship, both variables go in the same direction. If it's a negative relationship, the variables go in opposite direction. So in this case, money spent on a car and liking for that car have a positive relationship. So as more money is spent, so the money spent increases, what happens to liking for the car in a positive relationship?
Increasing?
It would increase, absolutely. So it would increase because that's just the nature of it. So I'll just underline the word increase. It would increase, it would not decrease because more money is spent. They're both going in the same direction. More money, more liking. So then the next question, does this mean that spending more money, that the money spent causes the change in the liking of the car? That the more money spent causes greater liking for the car? And in this case, this is the trick question. The answer is not necessarily. It could be that more money spent causes people to like the car more. But there are 3 alternate explanations possible. And this is what I want to go over with you today. So what are the 3 alternate explanations? So first off, it could be the way we've just posited. It could be that more money spent relates directly, causes people to like the car more. So it could be what we expect. Expected cause effect, it's called. X might cause Y. That could be the right explanation for this relationship. And what this would mean is that variable X, spending more money on the car, maybe it could cause people to like the car more. So let's just see if that's plausible. Could it be true? Could spending more money on a car cause people to like the car more? And so let me ask you, does this make sense to you intuitively? Is it possible, plausible, believable that people could like a car more if they spend more money on it? Could this be the right explanation? Does it make sense? What do you think? Arthine, you spent a bunch of money on a car. Do you think that for that reason you might like the car more? Can you imagine a scenario where that would cause you to like the car more?
Well, maybe, yeah, because like you're spending money on it, so you would expect to like the car more, or you would like the car more if you're spending more money on it.
Yeah. Like, yeah, like it could be so, right? You've taken a lot of your hard-earned money and you've spent it on this car. You sure, maybe you would like the car a lot because you spent so much of your hard-earned money on it. Yes, because we spend money, let's see if this works, on things we like. All right, let's think if the reverse could be true, because this is also possible in a correlational relationship. A reverse cause effect, Y could cause X. Let's see if that makes sense. Sometimes it doesn't. Is it possible that liking a car more could liking a car more cause someone to spend more money on that car? What do you think?
Yes, it would.
Yeah, if you really like a car, maybe you've saved up and you've decided to spend, more money on the car because you liked it, even if you couldn't really afford it. Sure, that's plausible. Sure, it could be that the reverse is true. We might really like a car and save up for it. What about some other variable, a third variable that we haven't thought about? An unknown variable that causes both X and Y. Can we think of any factor that might both cause someone to spend more money on a car and cause them to like the car a lot? So we have to think of something that would cause money spent on a car to increase and would also cause liking for a car to increase. And so maybe a factor like this might be, wealth. Someone who just has a lot more money might spend a lot of money on the car and really like collecting cars, something like that. There could be something like that. Wealth could be such a third variable. So these right here are these three explanations that sometimes give people a lot of trouble. The expected cause effect, X causes Y. Remember, our variables, X is money spent on the car and Y is liking for the car. And so we have to think of whether it's plausible. The reverse cause effect, Y causes X, and the third variable, some unknown factor that causes both X and Y. So when you're doing this in your homework, this is what you're going to be looking for. But I want to do a couple more examples of this because sometimes it's hard to wrap your head around these ideas. I'm going to spread this out a bit for us. So here's another one that I'm offering to you, and this one I'll invite you to do together. So here's the example. A significant negative relationship exists between concentration. Why did I say negative relationship? I think positive. Positive relationship exists between concentration on statistics homework and success in statistics classes. So first, let's name the variables X and Y. Can you please put something in the chat for the variables X and Y? I've got that pulled up, so I'm going to look for a few responses here. Just naming the variables. Okay. Couple more people just naming the variables. Katana, if you were going to name one X and the other one Y, usually X is the one that might be more likely to predict the other. Which one would you call X? Good, Shania. See if you can throw in an X and a Y in these just for the sake of thinking about it. I would say that X would equal what some of you have identified as concentration. Yeah, Arthine, I would say the same thing. Concentration, Shania, yeah, I think so too. Concentration, and we're putting specifically statistics homework, but it could be any homework. And let's put Y equals success. I'll put in class. All right, so those are our variables. So when we think about our explanations, we'll be thinking about those as representing X and Y. So now, I'm going to move this chat over so I can keep it in view. So now the next question, since it's a positive relationship, I had another example that was negative, and I think I just copied and pasted and didn't make the change. Since it's a positive relationship, we remember that a positive relationship means that the variables vary in the same direction. As one goes up, the other goes up. As one goes down, the other goes down. Since it's a positive relationship, does success in statistics class increase or decrease when greater concentration is applied to statistics homework? Greater concentration. Let's see some chat. Shanielle, Arthine, very good. Anyone else? Thank you for participating. I agree with you. It's going to increase. It's going to increase because we have greater here implying that one is going up, so we know the other one also goes up. It's this example as far as what's being described. So does this mean that, and this time give me a thumbs up or a thumbs down maybe, does this mean that higher concentration causes people to have greater success in statistics class? Can we interpret that from this finding? Maybe a thumbs up or a thumbs down, or else a chat, whatever's easier for you. Yes or no answer. It's a tricky one because actually our answer is no, or to be more specific, not necessarily. We cannot draw that conclusion. So let me just give you a hint for the exam. Anytime you see the word correlation and the word cause or causation in the same example, it's false. Correlation, the way it's often said, does not equal causation. You can never draw that conclusion. So keep this in mind, okay? So the answer to that would have to be no. We cannot draw that conclusion. It could be true, but we don't know that it's true. And here are our three possible things that could explain the relationship. So first off, the expected cause effect, that would be X causes Y. Concentration causes success in class. That's the first explanation. So is that plausible? Could it be that greater concentration causes greater success in statistics class? Is it possible? Does it make sense? I think it's possible. It could be, in fact, that concentration. Let me type, much better for me to type. Let me get rid of that. And the answer is definitely concentration could cause greater success in class. Practice makes perfect. So let's just say the more you concentrate, the better you practice. New neural pathways are formed as you concentrate. So yeah, that might be an explanation. That's possible. It's believable. It's plausible. All right, what about the reverse? What would the reverse explanation be? Y causes X. Here are our variables. What would the reverse explanation be? Could anyone put that into words in the chat, please? And I'll read what you put. What would the reverse explanation be? This is the directions going this way, Y causing X. And this one might read like this. Our Y variable is success in class, greater success in statistics could cause, is it possible that this could cause an increase in concentration on statistics homework? Is that plausible? I'm going to pick on someone particular. Shanielle, do you think it's plausible that individuals who are really successful in their statistics, but that causes them to concentrate more on their statistics homework? Yeah, Kiana, that's correct. Is this plausible? Shanielle, what do you think?
Yes.
How would that work? Why would someone who is more successful in statistics, why would that cause them to maybe work harder and concentrate more on their statistics homework? Can you think about that in your personal experience on a class that you're really successful in?
Well, being successful would help someone concentrate more because they are more interested in that type of subject.
Yeah, they've just gotten rewards. It would work like a video game. Like the more success you have, the more success you want to achieve, right? Like the farther along in the game you get, the more motivated and focused you are on persisting. So yeah, just having success can really motivate, having success can motivate persistence. You're feeling good about yourself. Definitely think about video games. All right, how about some third variable that both causes someone to concentrate a lot on their statistics homework and causes them to be successful in class? Can you think of any third variable? It would read like this. Some unknown factor causes both greater concentration and greater success. Can we think of anything? How about, let's see here. What if I ask, Kiana, can you think of anything that would both cause people to concentrate more on their statistics homework and cause them to have greater success in class? Anyone, try to think of any variable that might offer that relationship. I'll think of one. They're highly motivated engineering students, or like say their major field of study requires this strong grade in statistics class. So their area of study aligns with their statistics work. And so let's see. I don't like this example though, because it's too specific. I just want to say their level of dedication to completing their degree. That might cause them to just really concentrate on their homework. They want to get their degree done. And it might also cause them to be successful at all costs. They want to get their degree done. So I would say their dedication or motivation to complete their degree could be that unknown factor. And maybe there are others. Let's do one more example here. And here we have the negative relationship. A significant negative relationship exists between reward given for a particular task and liking for the task. Let's start by naming the variables. So what I mean by this, just to be sure, like I think of a child who's like rewarded for reading a book. And every time the child reads a book, they get a reward. And, you know, the bigger the reward. So that's what I'm looking at. So if that makes sense. That's what I was thinking of when I wrote this. So how could you name the variables X and Y, please? I'll wait. Oh, Shanielle, I just saw your answer. Oh, Arthine, excellent answers. I'll read them in a moment. Sorry, I didn't see these sooner. All right, I see your variables, Shanielle. Good, good. I'll go back to what you wrote just in a moment so that we have it. So the X variable, a couple of you have identified as the reward for, let's see, the amount of reward for a task. And Y is the liking for that task. So this is a weird one, isn't it? But it's actually true. So since it's a negative relationship, does liking for the task increase or decrease when a higher reward is given for completing the task? We have a negative relationship, remember, so they're going in opposite directions. So does the child like the book more or less when the reward increases? I see a message here. Question is number 2. Since it's a negative relationship, does liking for the task increase or decrease when a higher reward is given? Shanielle, correct. See a couple more. Shanielle said decrease, and that is absolutely true. As the reward amount goes up, reward goes up, liking goes down. And this is actually a sound principle. It's called the Premack principle in psychology. The more you reward someone for doing something, the less they like the task and the less they're likely to keep doing that thing once you stop giving a reward. Sort of a funny thing. All right. Does that mean, can we interpret this finding? Let's even write it that way. Can we interpret this finding to say that receiving higher rewards causes less liking for a task? So let me just write it that way. Can we interpret this correlation to say that receiving higher rewards causes people to like the task less? And so the answer here, can I just see a thumbs up or thumbs down? We have these two words in the same sentence. Thumbs up or thumbs down? Yeah, not necessarily. No, we can't interpret it that way. All right, it could be the way it is, but it might, there are 3 possible explanations. So the expected cause effect. Variable X causes variable Y, reward for the task, increases liking for the task. That's how we would read that. So is that plausible? And it is, in fact, it's actually demonstrably true. Reward for task, increased reward. Could it be that? And I'll just write yes, because I already told you it's true. It's almost like, well, if you have to pay me for this much money for it, it must be an awful thing to do. So if you pay your child a lot of money for reading a book, your child might come away thinking, well, books must be pretty horrible. There are points where that's a good thing, but in general, this is the phenomenon. The reverse cause effect. Let's see if this is actually plausible. Could it be that increased liking for a task causes the reward for the task to decrease? Is this plausible? Can you explain if you, Arthine, I have a hard time thinking of an example for this, but theoretically, this could be an explanation, but logically, I'm not so sure. Can you think of a way that this might be true, though? I just might be not thinking of a way. Oh, I can think of it. I think you're right, Arthine, as I write it down here. All right, what do you think about this, you guys? So you have someone who really likes to read, and they've been rewarded for reading, but they like to read before they even started the task, right? Like I did, right? And so then the more I like the task, could this cause a decrease in the reward? So now let's imagine that my parents are paying me to read books, but I like to read. I always have liked to read. Let's imagine this. And so eventually, maybe they're like, well, we don't need to pay as much. This person's just going to do it for free. Something like that. Or let's say I like gardening. I always have. And someone says, hey, can I hire you to take care of my garden? So they start paying me, but I'm really into gardening. I like it. And so I keep on gardening, even if they forget to pay me. I don't know. What do you think, you guys? Are those ideas plausible, or is it just made up stuff? Well, since nobody's arguing with me, I'm going to say, yeah, it's plausible. I just gave an example. And then there could be some third variable that both causes people to like a task more and causes them to be not paid very much for the task. Some third variable. I think that the third variable might be maybe innate enjoyment as a possible third variable that would both cause, no, maybe skill. Oh, what about good company? Good companionship completing the task. Might both cause me to like the task more and cause me to do it even without much of a reward. So this is kind of the idea of this. I wanted to go back to our previous example because we had a couple of third variable explanations that I didn't see. We were looking at the positive relationship between concentration on homework and success in class, and someone had said support. So could support be a third variable that would cause someone to concentrate more and cause them to have greater success. And I'd say that's an excellent example. And that brings me to just mention a message I sent to you yesterday. One of your classmates wants to start this idea of support. So this evening at 8 p.m., there is a link provided in the message I sent you. And if you go in there, there'll be hopefully a group of fellow students that you'll chat for a minute about what your goals are. Then everyone will kind of go into their own space and do their work. And then after 2 hours, you'll check back in again, revisit the group and talk about how you met your goals. And even that small level of support can really benefit you in terms of your concentration and sticking with your goals. And so I really encourage you, take your stats homework tonight, join into that group at 8, see if it helps. And that would be both supporting you in your work and supporting your classmate who's taking the trouble to go through this initiative. Okay, I want to go through, do you have questions about this content or about that group I mentioned before we talk a little bit about correlation matrices? Any questions? Okay, we'll go through this. I don't think this will be too difficult to understand, but I do have a few examples for you. So this is a correlation matrix. And so you see a lot of variables here. Variable, we have hours spent studying, exam scores, IQ scores, hours spent sleeping, and school rating. And this is an actual matrix from a study. And so they wanted to find out whether these variables correlated with each other. And this is how this is displayed. So instead of just doing one correlation between two variables, like instead of just correlating hours spent studying with exam score, they correlated hours spent studying with IQ score. They did a whole separate mathematical process. They correlated hours spent studying with hours spent sleeping, and hours spent studying with the school rating or the quality of the school that the student was attending. And so I just wanted to show you this because very often if you're actually reading a study, this is what you're going to see. So for example, we would read the matrix that the hours spent studying correlates very strongly with the exam score in this data set, 0.82. Remember, a correlation coefficient of 1 is perfect. The strength of the correlation ranges from 0 to 1. 1 is perfect. Every point is on the line. This is way up here. This is a very strong correlation, and it's 0.82. So that means that there's a really strong relationship, something like this, hours studying and exam. The points probably look something like this. Right? Who can tell what the correlation is? Can you read this chart? The correlation between hours spent sleeping and hours spent studying. Can you trace the matrix and find out what the correlation is and type it in? To do this, you just need to take your hours spent sleeping on one and then trace it over to the hours spent studying. Thanks, Kiana. Kiana says it's minus 0.22, and I would say this is correct. So here it is. If we go up, we have hours spent studying. If we go over, we have hours spent sleeping. We have a negative relationship. So it would be down here below 0, and it would be a 0.22. So it is a weak relationship, meaning that the more hours you spend studying, the fewer hours you spend sleeping. but it's weak. It's not that strong a relationship. What about exam score and what should we correlate? School rating. The quality of the school and the score on the exam. What is the correlation between these two? Type it in, please. And exam score, and I think you might have mistrained your eye. Exam score and school rating. So follow exam score over. Kiana, that's correct. Follow exam score over to the school rating column. So here's school rating, follow that down, follow exam score across. And what are you going to find? Yeah, the 0.23. So a weak relationship between exam score and school rating. Can anyone explain what this is about? Look at this pattern of ones going at the diagonal. What's that about? What does the score of 1 indicate in a correlation? So if the correlation coefficient, which is what we're looking at, indicated by R equals 1. What this means is that it is a perfect relationship. In other words, if we know the score on one variable, be better off if I'm typing here. Let's see. Let me just get a little text box in here and type a minute so I can go faster. So if we know this value on one variable, we know exactly what the value is on the other variable. Like if I know your weight in pounds, I can perfectly predict what your weight in kilograms will be. So here, what's correlated that has a perfect relationship? If we look at this circle right here, this one, what is it showing? What are the two variables that are correlated? It looks like hours spent studying and hours spent studying. It's the same variable. So of course it's perfect, right? Here we're correlating exam score with exam score. Of course it's perfect. IQ score with IQ score. Of course it's perfect because it's the same. I can perfectly predict IQ score from IQ score. Hours spent sleeping perfectly correlates with hours spent sleeping. So it's sort of redundant. It's unnecessary information because it's just always going to be the same. Whoops. Let me undo that. And so you'll find that that information is often not presented, right? So let me look at one more thing while we have this representation up. What about this fact right here? coming up. What about the fact that right here, we have a correlation of 0.48. And look at this, we have the exact same number. Right somewhere else. Where is it? Hours spent studying, hours spent studying, and IQ score. These people have a typo. Let's do a different example. Why do we have the exact same number here and here? What is the number I circled showing the relationship between? The two circled numbers, what are they showing the relationship between? What two variables? Can anyone read the matrix and find out what two variables are represented by the circled number? I'll type it in the chat in case you're having trouble hearing. Oh, thanks, Kiana. Anyone else? Kiana correctly identified by going up, school rating is one variable, and by going over, hours spent studying is the other variable. The reason it's here twice is because we have these right on both axes. So here is school rating again, and there is hours spent studying again. And I show you this by way of explaining why most of the time when a correlation matrix is depicted, it's shown maybe something like this. This is a really messy one. Here we're looking at relationship between happiness. The variables are happiness, exercise, sleep, job satisfaction, and pets. Aren't those funny little list of variables? You can see here that happiness corresponds perfectly with happiness, exercise perfectly with exercise because it's the very same number, very same number. And so that's redundant information. But you'll see that they left all of these blank. And they left them blank because the numbers would be exactly the same as the numbers that are here. So if you want to know the relationship for pets, you can't look here because they didn't fill in the numbers, but they did fill them in here. So for example, the relationship between the number of pets and happiness is 0.6590. 0.65, that's a moderate to strong relationship between pets and happiness. This little asterisk here means that the relationship is statistically significant. So when you see a little asterisk like that, it means p less than 0.05. The chances of getting this result by chance is less than 5%. So we can see here that there's a significant relationship in this study between job satisfaction and happiness. Can anyone identify another significant relationship, any relationship at all that's significant? Look for the little asterisk and then name the variables. You guys, I wish you were participating. Yeah, so what I'm asking, I'll type it in the chat. Can you identify any two variables that have a statistically significant relationship? Whoops, And I accidentally sent that just to Shanielle, so let me send it to everyone. The asterisks indicate significant. Just name any two variables. Our theme identifies job satisfaction and exercise, a 0.7312. Excellent. Yeah, there's a positive relationship there. Can anyone else find two variables that have a strong positive relationship that is statistically significant? So this is in your homework. This is why I'm going through this. It would help me if I could know whether you are understanding, but I'm not getting responses. I see here that we have a significant negative relationship between sleep and pets. So the more pets you have, the less sleep you get. That's weird, isn't it? I guess maybe you're spending a lot of time taking care of your pets. I don't know. Here's a significant negative exercise and pets. Yeah. That's exactly it. This is the one we just, wait a minute, exercise and pets. Yeah. So wait, I have exercise and sleep highlighted there. Why would this be true? Exercise and pets. That's what Shanielle just pointed out. Yes, that is a strong relationship. Why would you get more exercise if you have more pets? Shanielle, do you feel more sure now, like how to read this? Because you're right in how you read it. Yeah, good. Good. What's the relationship? Let me type it in here. What's the relationship between job satisfaction and exercise? What is the correlation coefficient? Job satisfaction and exercise. Yeah. Arthine. Others? Arthine, is it statistically significant?
Yes.
How do you know?
Because it's like closer to the 1.
Yes, but that means it's strong, but not necessarily significant. What else is by that 0.7312?
The
asterisk, yeah.
Yeah.
So this indicates the strength, but it might not be significant. That depends often on the number in the sample. Let's just look at a couple more depictions of this. In this case, look at this. We're looking at need for cognition, which is defined as the tendency to engage in and enjoy activities that require thinking, intelligence, social desirability, which is the tendency for individuals to respond in socially acceptable ways, and dogmatism, which is the tendency to hold principles to think you know it all. In other words, I would say that. Let's just say dogmatism is the tendency to think you know it all. All right, so look at these relationships. First off, here, instead of writing the ones, they just put dashes. They're all going to be ones. Dogmatism is going to correspond with dogmatism. They did not fill these in because they're redundant. They're all the same as what would be here. And you can see they don't have any of these marked as statistically significant. The strongest relationship appears to be between intelligence, your score on an IQ test, and need for cognition, like the preference for these activities that require a lot of thinking. The strongest negative relationship is between dogmatism, or thinking you know it all, and need for cognition. So the more you enjoy thinking about activities in general, the less you think you know it all. So that's just some interesting findings. And then I want to show you one more way of representing these data, and this one is in your homework. So this might seem a little trickier to you. In this one, there are more variables. Neuroticism, they're all defined down here. They don't matter for us right now. Extroversion, openness to experience, agreeableness, conscious rumination, emotional inhibition. There are actually more. I cropped this table. And so for that reason, they didn't have room to write all the variable names up on top. So instead, they just wrote the numbers of the variables up on top. So for example, variable 6, rumination, corresponds perfectly with variable 6, rumination. But they didn't have enough space to write it out, but that's what that means. And that's how you read one of these. And they're like that in your practice assignment. So you're going to be reading one of these, just answering a few questions. And that's just so you know how to read this. Here they included the ones. They did not fill in this, again, because it's redundant with what's already there. And they didn't list the variables up on top because they didn't have enough room. Okay, so that's the basics of what I wanted to give you in this. Now, what I'm going to do is take the data that you gave me in class, and I'm going to work that problem out on a video because we're out of our time, and I'll post up the video for you. And I really want you, well, you have to take all of your homework assignments in sequence, but if you finished your homework for chapter 8, take a stab at your practice. I'll put that example up and just follow it along. Do exactly what I'm doing in the example and you'll be in really good shape. And if you jump into your practice right now, you'll see the correlation matrix along with the answers. And there's just 4 problems in the practice and the answers are provided. And then you can jump into your homework and you'll be in really good shape. And come to our next class, that's our review for the final exam. Okay, I'm going to go through problems that are exactly like what's going to be on the final. And so if you come to the review, you'll have a much better chance of doing well on the final. That's what we're going to do. I'm just going to have a question and we're going to figure out the answer to the question and make sure you understand it. And those questions will be just like what you're going to see on the final. Okay. I'll put a message for all the students who are not here. If anyone needs to meet with me, I'm happy to stick around. Otherwise, I'll look forward to seeing you in our next class. Our last class. You should submit all of your missing work, Kiana. Anything that you're missing. I don't remember the date off the top of my head, but I'll post it in a message. I think it's even, you can absolutely submit your missing work. I think I had wanted it all to be due before Thanksgiving, but there's so much missing work. I'm extending that deadline. Get your work in, get your work in. Okay. When is the last day is a question that's asked. I think the last day that I can accept homework will be, it's going to be tight for me getting the grading done, but I'll go up until next week, Monday, and then the exam has to be completed by Wednesday, and you can't do the exam till you get your homework done. So get your homework done, people. I want you guys to do better. Thank you. I'll post that up what I just said to you so you can see it in writing too. All right, bye everyone. Bye. Katona, I think that you've left your screen